point 4, definitions of trig functions. Yesterday we talked about sine, cosine, tangent, cosecant, secant, and cotangent. And we talked about how sine was related to what? Cosecant, okay? So cosecant, because sine is really opposite over hypotenuse, but cosecant is what?
Hypotenuse over opposite.
Hypotenuse over opposite. Now, just one other thing that you probably can already infer from this, but if I have sine, then cosecant is just, and we talked about this yesterday, it's just reciprocal, so 1 over cosecant. Alright, so these are how they're related, they're reciprocals. Just as if I have cosine, it's the reciprocal of secant, and tangent is the reciprocal of
1 over cotangent.
Cotangent, and vice versa. If I have cotangent theta, it's the same as 1 over tangent, okay? So they're reciprocals of each other. The 6, they're paired up and linked together. All right? This should actually be somewhat of a review for you guys today from some of the stuff that we talked about in geometry. We're going to be kind of knowing our trig functions and kind of using it to find other trig functions. So if I give you, and we'll start out with a real easy one, given that cotangent theta equals 4, I want you to find tangent. So first of all, you need to think, how does cotangent relate to tangent? Stephen?
Cotangent.
1 over tangent. They're just what?
Reciprocal.
Reciprocals. So tangent's going to just be what?
1 over 4.
Okay, so tangent theta equals 1 over 4. What about, though, if I asked you, let's call this A, let's say that I asked you to find cosine theta.
4. Cosine.
Cosine theta. What you want to do is you want to think about what cotangent is. What is cotangent? What over what? Jack?
It's hypotenuse over opposite.
Adjacent. Adjacent over opposite.
Michael?
Just over what?
Okay, in terms of lengths of the sides of a triangle. Back.
Adjacent over hypotenuse.
Adjacent over hypotenuse. So we know that cotangent is adjacent over hypotenuse. Which means that 4 over 1 equals adjacent over hypotenuse. Therefore, the length of the adjacent side... Oh, I wrote hypotenuse. Sorry. Back up. Opposite. That makes more
I thought
sense.
something was up with that.
Okay.
What's for breakfast?
Opposite is the 1. You guys with me so far? See how it relates to the sides of the triangle? So what you can do now is you can draw your triangle. You can draw your theta. The adjacent side is 4. The opposite side is 1. And you can figure out what the hypotenuse is. What is the hypotenuse? Jack?
Square root over 1.
The hypotenuse?
Sir.
The square root of 17.
Square root what?
17.
How do you get that?
1 squared plus 4 squared. And the square root that.
You can either way.
You just pick whichever you like.
Well, so if I put this as theta right here, then this would be the adjacent side. So then I put the 4 here, and then the 1 there. So you can pick it, but it has to be in relationship to the sides.
So it doesn't really matter.
No, it doesn't matter. So I get my hypotenuse to be square root 17. Do you guys get that so far? Some of you are look confused. Should I back up a minute?
No.
So then we got 4 over radical 17 is cosine.
I need to pause.
I need to rewind like.
We know that cotangent, let me just quickly go over it. We know that cotangent is adjacent over opposite. And we know the value is 4. And we'll just make that a fraction, 4 over 1. So adjacent is 4, the opposite is 1, and I relate that to a triangle. So I put my opposite 1, my adjacent 4, and then I figure out the missing side, if needed. So now I go to cosine. What is cosine? What over what? Adjacent over hypotenuse. So adjacent over hypotenuse would be what in this case? What's adjacent over hypotenuse? 4 over square root of 17, which is what?
4 square root of 17 over 17.
Oh, I got it right.
Now, if I needed to, I could find the other other 3 remaining. I could find sine, cosecant, secant, and then tangent.
Wow.
Jack.
So if you did 4 over 17 times the 4 square root of 17 over 17, would that be 1?
Say that one more time.
If you did that equation 4 times square root of 17 over 17, would that equal 1? And wait, what's the point of this? What are you trying to do?
Okay. What we're trying to do, if I'm given one value of a trig function, doesn't matter what value, okay? If I'm given one trig value, I'm able to find the other 5.
Oh, yeah.
Because I'm able to fill in the missing sides of a triangle, and then from there I can piece everything together. Okay? Right here? I did. That's what this is.
Below your intelligence level.
That's what that is. Okay. Now this kind of pertains to what we talked about yesterday a little bit. Guys, you need to stop talking. Let's talk about the quadrant in which tangent is greater than 0 and sine is greater than 0. So, you need to figure out what quadrant, 1, 2, 3, or 4, is tangent greater than 0 and sine greater than 0. Now, once you guys kind of start getting the hang of it, you'll kind of be able to figure it out. The value. So meaning where tangent is positive and sine is positive. That's an and sign.
Oh, that was my question.
That was like the fish from yesterday.
Anyways,
Jesus fish.
okay. So this is one of the easiest kind of ways, or one way that you can kind of think about it. I kind of draw a bow tie, and you'll kind of see this in your unit circle. Now, everything in the first quadrant, because you know that the coordinate point here is positive, positive, right? Everything in the first quadrant is going to be positive, right? Because I have positive here, positive here. And we also know the hypotenuse is positive. Now, over here, we always know that the hypotenuse is going to be positive. This down here, though, is what? Negative, negative, positive, negative. So, tangent is positive here. Sine is positive here. Because everything's positive, right? So, we know that everything is positive in the first quadrant, but let's check the other ones. Tangent is what over what?
Opposite over adjacent.
Opposite over adjacent. So if I go to the second quadrant, Opposite over adjacent, is it positive here?
No.
What about here? Opposite over adjacent?
Yes.
It is. So then you go to, is sine positive here? No, because it's opposite over hypotenuse. So it can't be in the third. Is tangent positive here? Opposite over adjacent. Is sine? No. So the only one that is positive for both of them is in the first quadrant. Okay?
How do you know where to take the tan or the sine from?
That's the problem.
Which angle is?
Oh, it's opposite.
It's always that one.
What is that called? Alpha, but it's also called the what angle?
Reference angle.
The reference angle. Always from there.
Silly.
Alright, what about instead of being tangent positive and sine positive,
Silly.
what if we have cosecant less than 0? Oh, that's not right. Oh, well. Okay, and someone give me another one.
Secant,
Tangent, what you want, negative or positive?
Negative.
Let's make it positive. Alright, so we're looking for a quadrant where cosecant is negative and tangent's going to be positive. What is cosecant? What over what? Yeah.
Hypotenuse over adjacent.
Hypotenuse over opposite. Tangent, we already talked about this one. It's opposite over adjacent. So in what quadrants is cosecant negative? What quadrants? There should be 2 of them.
CSC.
2 to 3.
How you go over the top?
No, 3 and 4. No.
3 and 4. 3 and 4. 3 and 4.
Are we in agreement yet?
3 and 4.
3 and 4. Because opposite over hypotenuse is 3 and 4. So 3 and 4, cosecant's negative. In what quadrants are tangent going to be positive?
3.
3 and what? And 1. Now, what's the case for both of them? Which one is true?
Right.
3.
3. So it has to be quadrant 3 where both of those hold true. Okay?
This video.
Yep.
You didn't show that graph for like 10 more seconds.
This one?
Yeah.
Yes.
You know what? I really did that.
Thank you.
Yeah. Okay. A lot of the times they're going to be more specific though about what quadrant you're going to be in because sine is not always going to be positive. It's not always going to be in the first quadrant. It can have respects to the other quadrant. So like what we kind of talked about in the beginning, let's go back to that one more time. Given that the angle is going to be in the third quadrant and that we know that tangent is equal to 8 over 5, we want to find the other 6 trig functions. So what we're going to do is we'll make our coordinate plane. I know I'm working in the third quadrant, so I'm going to go ahead and make my triangle in the third quadrant. And again, just like what we talked about in previous sections, I'm drawing it to the x-axis, and I'm going to be using this angle in here as my reference, or my theta.
Do you always draw the triangle to the x-axis?
Always to the x.
That was me.
Now, tangent Opposite over adjacent. So from this angle, this is opposite. This is adjacent. But look at it. Does that make sense in respect to what quadrant it's in? Probably.
Well, if they're both negative, then it's going to be positive.
Okay. So being in this spot right here, this coordinate point is going to be negative, negative. So it can't be a positive 8 over 5, but that's only if they're both negative because they're in the third quadrant. Now I want to find the other 6 trig functions, which means I need the hypotenuse. It's 5?
5 other. No, 5 other.
Well, okay, sorry, the 5 other. Well, what's the hypotenuse?
You gotta find that.
So what do we get?
Root of 89.
Is it 89?
Yes.
Okay. Does it simplify?
Yeah.
Oh.
To what?
What?
To what?
I answered the first one. Somebody else did.
It doesn't. Square root of 89. Alright, so we need to find sine, cosine. We know tangent. We're going to then find cosecant, secant, and then finally cotangent. Now, cotangent should be easy because it's just the what? Okay? 5 over 8. What is sine going to be? And we'll use the triangle's reference. Negative 8 square root 89. We'll go ahead and rationalize that in just a minute. Colin?
Shouldn't you be saying sine alpha?
Okay. So, and we'll talk about this a little bit more in the unit circle. Technically, theta is that angle. But when we actually figure out the ratios, it comes from that, and it's the same thing. So they're the same thing. We just use the reference to figure it out. Cosine. Negative 5 over square root of 89. We'll go ahead and flip them. Square root 89 over negative 8. Square root 89 over negative 5. I'm going to go back and rationalize these. So it's going to be negative 8 square root 89 over 89. And then negative 5 square root 89 over 89. And those are those other 5. Alright, one more, and then we'll be done. This goes back to that positive negative thing, okay? Where the functions are positive and where they're negative. So if I want to know what the signs are for sine, cosine, tangent, cosecant, secant, and cotangent of negative 60, I just need to know what quadrant it's in. So if I'm talking about negative 60, what quadrant will it be in? 4. Remember, we go down. So negative 60, I'm going down like this, so negative 60. I draw my triangle again, perpendicular to the x. And then I just think about what these are.
So 36 and 90 triangle.
It will be. That's positive. I actually don't need the angles. It's good to know, but I don't need that for the sines. This right here is going to the right, so this is going to be positive. This is coming down, so that's going to be negative. So I have all the signs of my triangle. So when I go and I want to know what the sine, what sine is, it's opposite over hypotenuse. So sine would be what? Negative. Cosine would be what? Positive. Tangent would be negative. Now the rest of these, cosecant is really just the reciprocal, so this should be negative. This should be positive and negative. Anyone not understand why they came up negative or positive? Michael?
I know what it is, but when they ask us to find the sign, that's what we do.
The signs of it, yeah. Yeah. Just positive or negative. Bryce?
I think you meant to have cotangent.
Thank you.
You don't have to erase the tan, you just have code.
Cotangent.